Hi, welcome back to my class in Spherical Trigonometry. For today, we will solve more examples on problems involving right spherical triangles and using Napier's rules and the mnemonic device. And after these two more examples, we will have the solution of oblique spherical triangle. We will define oblique spherical triangle, and I will list down the formulas that may be used for solving oblique spherical triangles. For our example 1 for today, consider the following problem. Example, solve the following right spherical triangle ABC. Given that small a, this is a side of right spherical triangle, and its measure is 87 degrees 16 minutes, which means that the length of the side small a is given by the angle subtended by this side small a to the center of the sphere. And that central angle has a measure of 87 degrees 16 minutes. One of the surface angles is given, angle B, and its measure is 38 degrees 45 minutes. And the right angle is at vertex C, or the right angle is angle C. It is a surface angle and it measures 90 degrees. To solve this right spherical triangle, we apply Napier's rule. Again, we state the Napier's rules, and there are two. The first one states that the sine of the middle part is equal to the product of the tangents of the adjacent parts. We write that in symbols. The first Napier rule states that the sine of a middle part is equal to the product of the tangents of the adjacent parts. Tangent of an adjacent part and tangent of another adjacent part. Again, the first Napier rule states that the sine of the middle part is equal to the product of the tangents of the adjacent parts. And the second Napier's rule states that the sine of a middle part is equal to the product of the cosines of the opposite parts. We write that in symbols. The sine of the middle part The second Napier's rule states that the sine of the middle part is equal to the product of the cosines of the adjacent parts. For our first example, we construct the mnemonic device. The given is a right spherical triangle with right angle at C. C is 90 degrees, indicated by this small square. And then we have angle A and angle B. The angle B, the surface angle B is given 38 degrees 45 minutes. The side opposite the surface angle A is given, and it measures small a is it measures 87 degrees 16 minutes. Small a, the side opposite angle A is 87 degrees 16 minutes. And the side opposite, the surface angle capital B is small letter b. And we will have to find small letter b and angle, surface angle capital A. We also need to find the side opposite the right angle C, denoted by small c. In a right triangle, we said before that since one of the angles is fixed at the right angle, only 5 parts will vary. And we write these 5 parts in a circle, and we call them the 5 circular parts. We draw a circle, we divide them into 5 equal parts. And since the angle C is fixed at 90 degrees, the 5 parts that may vary are A, small b, capital A, small c, and capital B. And we place these 5 parts in this circle. We start with the small a, and we go in counterclockwise direction, small b. And then angle capital A, small c, and angle capital B. But these are not the parts that we will use in writing the equations using the Napier's rules. The parts of the triangle, the right spherical triangle that make up the right angle C are small a and small b. And in the mnemonic device, we write them as is. We construct again a circle, and we divide it into 5 equal parts. In the mnemonic device, the sides, the parts of the right spherical triangle that form the right angle C, small a and small b, we write them as is in the mnemonic device, from which we will write the equations using Napier's rules. And the other 3 parts, we write them as complement. We start with A. In the mnemonic device, we write it as complement of A, denoted by A prime. Now, A prime and A, these 2 angles are complementary angles. They add up to 90 degrees. The complement of A, we denote by A prime, and the complement of A prime, we denote by capital A. In the mnemonic device, instead of writing small c, we write complement of small c, denoted by C prime. And finally, the angle B, instead of writing simply angle B in the mnemonic device, we write complement of B, denoted by capital B prime. Now, the parts of the right spherical triangle that we want to find are the surface angle capital A, the side small b, and the side small c. Suppose we start with surface angle capital A. We take capital A prime as the middle part, and the adjacent parts are B and C prime, and the opposite parts are A and capital B prime. Now, if we use the first Napier's rule, the sine of the middle part is equal to the product of the tangents of the adjacent parts. But these adjacent parts B and C prime and C are not known. They are also unknown. Therefore, we cannot use the first Napier's rule to find angle capital A. Suppose we use the second Napier's rule, and it says the sine of the middle part A prime is equal to the product of the cosines of the opposite parts. Now we check small a is given and capital B is given. Therefore, we can find the surface angle A using the second Napier's rule. And we write the equation using the second Napier's rule. The sine of the middle part, we write by the second Napier's rule. The sine of the middle part, sine of capital A prime, is equal to the product of the is equal to the product of the cosines of the opposite parts. These are the opposite parts, small a and capital B prime. Cosine of small a multiplied by cosine of B prime. Now, to remove the complement from sine A prime and cosine B prime, we apply the complement angle theorem, which we have stated before. And the complement angle theorem states that the trigonometric function of an angle is equal to the cofunction of the complement of the angle. Hence, by that complement angle theorem, the sine of A prime is equal to the cofunction of sine, which is cosine. Right? By complement angle theorem. By complement angle theorem, the trigonometric function of this angle is equal to the cofunction of sine, which is cosine. Cofunction of the complement of A prime. The complement of A prime, as I said earlier, is A. Is equal to cosine of small a multiplied by cosine of B prime. We also apply the complement angle theorem to cosine of B prime. Cosine of B prime by complement angle theorem is equal to the cofunction of cosine, which is sine, and sine of the complement of B prime. As I said earlier, the complement of B prime is B. And from this equation, we can now solve for A. A now is equal to inverse cosine or shift cosine of cosine A multiplied by sine B. And we this is equal to shift cosine or inverse cosine cosine small a is given 87 degrees 16 minutes. Multiply by sine of angle B. Angle B is given there, it's 38 degrees 45 minutes. Sine of 38 degrees 45 minutes. We now compute the exact value of angle A using scientific calculator. And don't forget to have the mode of your calculator in degrees. We now compute the value of the surface angle A using our calculator. Scientific calculator, we write shift cosine of cosine 87 degrees, cosine of 87 degrees and 16 minutes multiply by sine of 38 degrees, sine of 38 degrees and 45 minutes. And you should get 88. Our angle A is 88.289537. 537,319,133. Depending on your calculator, if you have a good calculator, your calculator will display more number of digits. Now this is in degrees. We now give our answer in degrees, minutes, and seconds. Take the whole number part of this decimal number. Angle A equals 88 degrees. In your calculator, you subtract. You have this answer in your calculator and do not remove that from your calculator. In your calculator, you subtract 88. You write minus 88. And you will get this decimal number 0.289537319,133. And multiply that decimal number by 60. Now, why 60? Because this decimal number 0.289537319,133 is degree, and we want to convert that to minutes. And we know that 1 degree equals 60 minutes. Hence, we multiply this decimal number 0.289537319,133 by 60. And you should get 17.3722 3914 880. From this decimal number, again, take the whole part the whole number part of this decimal number, which is 17. That's 17 minutes. And you still have this answer in your calculator. From your calculator, you subtract, you write minus 17. And you will get this decimal number 0.372. 0.372 sorry, 0.372 23914 880, and multiply that decimal number. That decimal number is in minute, and 1 minute equals 60 seconds. Now to convert this minute 0.3223914 to seconds, we multiply that decimal number by 60. And you should get 22.33 434 888 048. Now we round this off now to whole number. This is now in seconds, and we round this up to whole number. After the decimal point, you round up this digit. If the number to be rounded up is 5 or more, you add 1 to the preceding digit. But since the number to be rounded off 3 is less than 5, we simply drop 3 and all the digits to its right, and we write 22 seconds. Written 22 double prime. And that's the surface angle A. Next, we find we start with small b. The side is small b. By using Napier's rule number 1, or the first Napier's rule, it says the sign, we now take small b. If we want to find small b, we take small b as the middle part. And by Napier's rule number 1, the sine of small b is equal to the product of the tangents of the adjacent parts. Small a and capital A prime are the adjacent parts to b, and capital B prime and small c prime are the opposite parts. The parts opposite the middle part is small b. Since small a is given, and it's equal to 87 degrees 16 minutes, and we have found the angle capital A, 88 degrees 17 minutes and 22 seconds. We can now find this side small b by Napier's rule number 1, and we write the equation using Napier's rule number 1. We write by Napier's rule number 1, and we take small b as the middle part. The sine of the middle part, sine of small b. is equal to the product of the tangents of the adjacent parts. Tangent of small a times the tangent of capital A prime. Now we have to remove the complement from tangent of A prime by applying the complement angle theorem. By complement angle theorem, the tangent of capital A prime is equal to the confunction of tangent, which is cotangent. Confunction, the tangent of capital A prime equals the confunction of tangent of the complement of A prime, which is A. Hence, this equation can now be written as sine B equals tangent of small a. And tangent of A prime by complement angle theorem equals confunction of tangent is cotangent. And complement of A prime is A. And by using one of the reciprocal relations, which is a trigonometric identity that you must have taken in plane trigonometry, cotangent of A is the reciprocal of tangent. So we write cotangent A as 1 over tangent A. We have sine B equals tangent A multiplied by cotangent A is equal to the reciprocal of tangent. Reciprocal of tangent is written as 1 over tangent A. And sine B, sine small b is equal to tangent A multiplied by 1 is tangent A. Tangent small a over tangent capital A. And from here, the side B is shift sine of tangent of small a over tangent of capital A. And is equal to shift sine of tangent. The small a is given and it is equal to 87 degrees 16 minutes. Over tangent of capital A. Tangent of capital A we found is equal to 88 degrees 17 minutes. 88 degrees 70 minutes 22 seconds. Again, we use our calculator to find this value, the length of side B. Take your scientific calculator and the mode should be in degrees. To calculate shift sine or inverse sine of tangent of 87 degrees 16 minutes divide by tangent of 88 degrees. Seventeen minutes. And 22 seconds. Ship side of tangent of 87 degrees, 16 minutes. Divide by tangent. I forgot to write tangent. Divide by tangent of 88 degrees, 17 minutes, 22 seconds. And you should get 38.72066. 38.72066 12644. 339 degrees. Again, we give the final answer in degrees, minutes, and seconds. In your calculator, do not remove your answer. Take the whole number part of this decimal number, which is 38 degrees. And in your calculator, you subtract. In the answer in your calculator, you subtract 38 degrees. Minus 38, and you should get the decimal number 0.206612644,339, and that's degree. And to convert that degree to minutes, we multiply that decimal number by 60 minutes, because we know that 1 degree equals 60 minutes. So we multiply this decimal number by 60, and you should get 43.239, 43.239, 6758, 660, 3581. Again, do not remove this answer from your calculator. Take the whole number part. This decimal number is in minutes. Take the whole number part of this decimal number, which is 43. And that's 43 minutes written as 43 prime. In your calculator, you subtract 43 minus 43. And you should get the decimal number 0.239675866033581, and multiply that decimal number by 60, because 1 minute is 60 seconds, and this decimal number 0.239675866033581 is in minute. and we want to convert it to seconds. Hence we multiply the decimal number by 60 because 1 minute equals 60 seconds. And you should get 14.380. 0.55196. One 48827. Now this decimal number is in seconds. We now round it off to whole number. After the decimal point, we round off the digit after the decimal point, which is 3. And the rule says if the number to be rounded off is 5 or more than 5, we add 1 to the preceding digit. But the number to be dropped is 3, and it is less than 5. So we drop 3 in all the digits to its right, and we just write 14 seconds. This is the measure of the side small b opposite angle B. Now the only part that is left for us to find is the small letter C, the side opposite angle, the given right angle C. Now if we want to find small c, we take small c prime as the middle part, and capital B prime and capital A prime will be the adjacent parts. Small a and small b will be the opposite parts. Since we know small a, we found small b, you can use the Napier's second rule that says the sine of c prime is equal to the product of the cosines of the opposite parts. And we also found capital A and capital B is given. So you can also use Napier's rule number 1 that says the sine of the middle part is equal to the product of the tangents of the adjacent parts. I will use Napier's rule number 2 to write the equation from which we can find small c. We write by Napier's rule number 2 that says the sine of the middle part, sine of small c prime is equal to the product of the cosines of the opposite parts. Hence, sine of small c prime equals cosine of small a and multiplied by cosine of small b. Now we want to remove complement from sine of c prime. And by complement angle theorem, the sine of small c prime is equal to the compunction of sine, which is cosine. Cosine of the complement of small c prime, which is small c. And cosine of small c equals cosine of small a multiplied by cosine of small b. And from this equation, from this last equation, small c now is equal to shift cosine or inverse cosine of A multiplied by cosine of B. And we substitute small a which is 87 degrees 16 minutes. Small c now equals cosine, shift cosine of small a is 87 degrees 16 minutes. That's given. Multiply by cosine of small b, which we found to be 38 degrees 43 minutes and 40 seconds. Again, we used the calculator to find the value of small c from this expression. We now find the value of c from this equation using calculator. We press shift cosine of 87 degrees. Cosine of 87 degrees and 16 minutes. Cosine of 87 degrees, 16 minutes. Multiply by cosine of 38 degrees. (43 minutes) and 14 seconds. Cosine of 87 degrees, 16 minutes, multiplied by cosine of 38 degrees. (14 minutes). And you should get 87.8677. Small c, 87.677. 8786. 8677. 53477. 2496. Now, do not remove your answer from your calculator. This answer is in degrees, but we will give our final answer in degrees, minutes, and seconds. We take the whole number part. We have 87 degrees. Small c is 87 degrees. In your calculator, you subtract 87 minus 87, and you should get the decimal number 0.867753477246, and the decimal number in your calculator is in degree. To convert that to minutes, we multiply that decimal number by 60 minutes, because 1 degree equals 60 minutes. Hence, the decimal number in your calculator, multiply that by 60, and you should get 52.065. (65) 20863. 20863. 49815. And this decimal number is in minutes. Again, take the whole number part of this decimal number, which is 52, and that's 52 minutes. And in your calculator, you subtract 52. In the decimal number in your calculator, you subtract 52 minus 52. And you should get this decimal number 0.0652086349,815. And that is in minute. To convert that to seconds, we multiply that decimal number by 60 because 1 minute is 60 seconds. In your calculator, multiply the decimal number by 60. And you should get 3.91251. 3.91251 8894. This decimal number is in seconds, and we round this off now to whole number. And round off the digit after the decimal point 9. Since 9 is more than 5, we add 1 to the preceding digit 3. And this decimal number to rounded off to whole number is 4. And we write 4 seconds. Now we have found all the unknown parts of the given right spherical triangle. In the given right spherical triangle, the right angle is at the surface angle C or the included angle C. And the side small a is given 87 degrees 16 minutes. And also the surface angle B or the included angle B is given 38 degrees 45 minutes. The unknown parts are small b, the surface angle capital A, and the side small c. Now we will verify the properties of spherical triangles. Spherical triangles have certain properties. The first property is that the maximum value of a side of a spherical triangle is 180 degrees. We write properties of a spherical. The first property again is that the maximum value of a side of a spherical triangle is 180 degrees. That implies that any side has a value of less than or equal to 180 degrees. The maximum value for a side of spherical triangle is 180 degrees. Now we check. Small a is given and it's less than 180 degrees. We found the small b and its value 38 degrees 43 minutes 14 seconds is less than 180 degrees. And we found the side small c opposite the right angle capital C with its value equal to 87 degrees 52 minutes 4 seconds, which is less than 180 degrees. Now, the second property of a spherical triangle is that the maximum value of an angle, surface angle of a spherical triangle is also 180 degrees. We write the angle for a spherical triangle can have a value of maximum of 180 degrees. We check our answer. The right angle C is given 90 degrees and it's less than 180 degrees. The angle capital B is given 38 degrees 45 minutes and it's less than 180 degrees. And we found the angle A 88 degrees 17 minutes 22 seconds and it's less than 180 degrees. So for our right angle our right spherical triangle with its parts satisfies the first two properties of spherical triangle. The third property of spherical triangle is that the sum of the sides of spherical triangle is less than 360 degrees. And we write that the sum of the sides is less than 360 degrees. Our sides are denoted by small a. You can add 87 degrees. Now we check. We get the sum of the sides of our right spherical triangle. And the sum of the sides should be less than 360 degrees. Small a is 87 degrees and 16 seconds. Plus the side small b is 38 degrees 43 minutes (40 seconds). And the third side, small c, is 87 degrees 52 minutes and 4 seconds. The sum is 213.86 degrees, which is less than 360 degrees. Hence, the third property of spherical triangle is satisfied by our right spherical triangle. The fourth property of spherical triangle is that the sum of the angles of spherical triangle is between 180 degrees and 540 degrees. The fourth property of spherical triangle, the sum of the angles is between 180 degrees and 540 degrees. So we check for our right spherical triangle if this fourth property of spherical triangle is true, and it must be true. The right angle is at C equals 90 degrees plus the angle capital B 38 degrees and 45 minutes, and our angle capital A 88 degrees 17 minutes and 22 seconds. And the sum of the three angles of this right spherical triangle is 217.04 to 2 decimal places. And it is greater than 180 degrees but less than 540 degrees. Hence, the fourth property of spherical triangle is satisfied by our right spherical triangle here. The fifth property of spherical triangle is that the sum of any two sides is always greater than the third side. We write sum of two sides is greater than the third side. The three sides of spherical triangle, in particular this right spherical triangle, the three sides are small a, small b, and small c. And the P property says that if you take the sum of any two of these three sides, the sum will be greater than or more than the third side. For instance, if you get the sum of the sides A and B, the sum A plus B is greater than C. And you can see that A plus B, A is 87, 38. That's approximately 125 degrees, and it's definitely greater than the third side, 87 degrees. Also, if you get the sum of these sides A and C, the sum A plus C is greater than the third side B. We check 87 and 87, that's approximately 174 degrees, and that's the sum of A plus C, 174 degrees, is greater than B, 38 degrees. And lastly, if you take the sum of the sides B and C, the sum B plus C is greater than small a. We check small b is 38, small c is 87 degrees, and that's approximately 125 degrees. The sum of b and c is approximately 125 degrees, and that sum is greater than a, 87 degrees, 16 minutes. Hence, the P property of spherical triangle is satisfied by our right spherical triangle. The sixth property of spherical triangle says that the side opposite of a larger angle, included angle, is longer than that of the angle with a smaller included angle. Again, if the property says that we compare angles A and angle B. Angle A is 88 degrees. And the side opposite angle A is small a, 87 degrees. And angle B is 38 degrees, 45 minutes. And the side opposite angle B is small b, 38 degrees, 43 minutes, 14 seconds. Hence, angle A has a larger opposite side than the side opposite angle B, because angle A is greater than, more than angle B. We take angle C and angle A. Angle C is the right angle, 90 degrees, and the side opposite angle C is 87 degrees. And angle A is 88 degrees. The side opposite angle A is 87 degrees, 16 minutes. And between angle C, capital C, and angle capital A, the larger, the bigger angle is the right angle C, 90 degrees. And the sixth property says that the side opposite the larger angle has a bigger measure. Now we compare the side opposite angle C, capital C is 87 degrees 52 minutes. And the side opposite angle A, small a, 87 degrees 16 minutes. And you can see that small c, side C here is larger, bigger than the measure of side small a by minutes. That's the sixth property of spherical triangle. We now take another example for solution of right spherical triangle.